Hey everybody, welcome back. I hope you're all having a good time at home, staying safe and everything. So today we're going to be jumping around a little bit. We're on page 590 to start. So we're jumping around a little bit. We're not going to be going necessarily in order through the chapters anymore. But today we're going to be learning a little bit about volume. So to start, we're going to go through some vocabulary. We're going to do volume of spheres, cones, and cylinders. So we're going to be jumping around a little bit in the book. Just slow it down. You can pause it when you need to go to different pages, but we'll get through it. So right now, page 590, we're just going to do the book for the vocabulary, and then I'll go on to something else. But anyway, volume. This is the measure of space occupied by a solid, and volume is measured in cubic units. So for this, centimeters is cubic centimeters, inches, cubic inches. So when it says a solid, that's a three-dimensional object. In this case, we're going to have cones, cylinders, and spheres. So let's go on to a cylinder. A cylinder is a three-dimensional figure with two parallel, congruent, circular bases connected by a curved surface. So that sounds confusing. I'll explain that a little bit more. There's actually an example image underneath of what a cylinder is. So, three-dimensional figure, that's just any figure that's like in real life, everything's three-dimensional, not just a picture on a piece of paper. Congruent circular bases. So the circles on this image are the same size. Both of these are the exact same size, and they begin running parallel to each other. So they'll never meet if they continued on a plane. Now, circular, connected by two parallel lines. It's always going to look something like this. This is a cylinder. If you know what it looks like more than anything, I'm happy with that. All right, so from page 590, we're going to jump to page, let me find it. Page 598. And now we're talking about cones. So, a cone is a three-dimensional figure with one circular base. So this has one circular base, and it's connected by a curved surface to a single vertex. So it's kind of like an ice cream cone. Think of an ice cream cone when you think of a cone. Something like that. Cylinder, think of cans. Cans are good ideas to think of as cylinders. And last is a sphere, which I'm pretty sure you're familiar with. It's like a ball, a sphere. And from 598, we're going to page 606. So we're jumping 8 pages each time. And on page 606, we have a sphere. Where's the... Oh, it's actually 605. So a sphere is a set of all points in a space that are given distance, known as the radius, from a given point. So that's just saying from this point in the middle to anywhere on the outside of the sphere, it's the same distance. It's a ball, a perfectly circular ball. That's what a sphere is. So don't really worry about the definition too much as it's given in the book. It's good to look back on to know an exact definition. Oh, you can't even see it. It's good to look back on to know an exact definition, but it's also a little complicated. So just think of it as a ball. And this is your center, the exact center. The radius is halfway through the whole thing. The diameter the whole way through, radius is half that. So it's just from the outside to the center dot. And that's going to be important for all of these. I'm going to go back just in case I didn't have that definition on camera earlier for a cone right there. So also, this is also your radius right here. From the outside of the circle to the center. It's always going to be in the circle. Halfway from the outside of the circle to the center. That's your radius. Halfway across. That thing right there. And careful when it does something like this. That's a diameter. Your radius is half of this number if it's a full line across. So we'll get into more of that now. All right. So I'm going to give you some examples now And maybe just write some of this down. This will be important to write down too. And just to have with you. So, let's see if I can. I'm going to flip this. Doesn't want to flip. All right, we'll work with it. So, here we go. We have pi r squared. This is my cone. Here's my cone up here. And now, I'm going to teach you a formula to find the volume of a cone. We're going to go through how to solve for the volumes of each cone. So, to start, we're just going to work with a cone for now. Don't worry about anything else. We have pi r squared times h over 3. And now you're probably wondering, what does that mean? So here's our cone. My pi, that's just a number. That's 3.14. You don't have to remember that. I think there's a pi symbol in your calculator you can hit, but it's just going to put a certain number in there for you. R squared, that is r, which is your radius. This line from the center of the circle to the outside of the circle. If it's going all the way across, you have to take half of that, like I showed earlier. So just this part right here. Whatever that number is, you plug it in for r. That squared is that number times itself, r squared. H is our height. That's the distance from this center point in the circle all the way to the top. So this little dotted line right here. And these will be given to you on the worksheet. You'll have these numbers in there. You just have to figure out where to put them in your formula. So let's do an example. If I have this cone, let's say my height is 9. And my radius is, let's say, 6. So now we have to figure out what to do with our formula. Well, let's think about what this is. 6, we'll say inches. Inches. 6 inches is the outside of the circle to the center of the circle. That's a radius right there. Just to the center, not all the way through, just to the center. So 6 is my radius. So we plug that in into the formula. Pi 6 squared. Just the 6 is squared, nothing else. Times h, which is my 9, because it's the height from the center of the circle, which is the bottom of this, it's my base, to the top of the cone. That's 9 over 3. And now we can solve this. So, before I even multiply by pi, you can plug this into your calculator, it'll turn out. But I'm going to do this just right now here. So 6 squared, 6 times 6 is 36. Times 9 divided by 3 is 3 times my pi. So I still have pi there. Now, 36 times 3. I'm going to use a calculator for this. Plus times the pi. Put that in my calculator. You could put it in the calculator from the start. But, pulling up the calculator, I'm going to put 36 times 3 times pi. And I'm doing this on my phone because I don't have access to my iPad right now because I'm recording with it. But if I show you this, 36 times my 3 times pi. I found my pi over in here, so it might be similar on your iPad. My pi is right there. So then it equals 108 pi. So if you want, you can write it as 108 with the pi symbol, or you can just round it to one decimal place. So I could write 339.3 inches cubed. Remember to write down what we have, what the unit is. Inches cubed. Not just inches, it's cubed inches for volume. Or I could write down 108 pi inches cubed. But either one I'm okay with. This one might be a little better depending on the situation because it's more exact. You don't really use this when you're measuring things because it's hard to represent what that is. So either one of those, though, I'll be okay with. And that's how we do a cone. So you can play this back, go through it again. You can change these numbers, but they're going to go in the exact same spot. So if I made this a 12, it's still going to go in for the h and be divided by 3. no matter what this number is, it's always going to go in for h because it's from the base to the top. They can flip the cone in any situation, any orientation they want, and this line right here is your height. This will always be your radius. If they do something like this though, and they make this 12, your radius here, if it's a full line, you see a full line going across the circle, your radius is half of that. Because it's only from here to the center. They're saying this line right here is 12. We just want this to the center. So half of that is 6, so your radius would be 6. That's only if the line goes all the way across. If it's just halfway across the circle, that number right there is all you need. All right, so let's try it with the next one, a cylinder. This formula is a little nicer, just not a whole lot different, but it's pi r squared h. So pi r squared h. Pi is still 3.14, r is still my radius, and h is still my height. So my height is going to be from this dot down to this dot. Just down, your whole height is the side length down. Or if they have something in the middle. But it'll be the side length down, because from top to bottom, that's my height. If they orient this something like this, your height's still this sides. It's not going to change it the way they orient it. Your formula still works with this. So, let's try plugging this in. Let's say we have a height of 4 and a radius, or let's do this full length is 6. No, I don't like that. It's 2. 2 is my full length across this line, because it's a full line here. So it's a full line, we take half of it. Half of that, because it's my radius, is only to this center dot. This is a full line all the way across that. So 2 is not my radius, it's my diameter. We need half of that. So half of 2, 2 times 1/2 is 1. So I have pi times 1 squared, just my 1 squared, nothing else, times my h, which is 4, it's my height, times 4. So we have 1 squared is 1, times 4 is 4, times pi. You can leave it like that. Let's say the unit is centimeters. And then we'd say centimeters cubed. If it doesn't have something up here, you could just say units cubed. But if it has a label like centimeters or something, you need to put centimeters cubed in your answer. So let's say we have 4 pi, pi, which is 12.6 about centimeters cubed. All right, so that is cylinders. If it's just to this dot, you just put that number in. If it's all the way across, you put half that number in. So hopefully that makes sense. If you have questions about that, you can ask me and I can help with that. Email me if you have any questions. I can maybe go through another problem if you want me to. However I can help, just let me know. Email me. I can go slower. You can always go back and play the video back. Whatever helps for this. So, let's do sphere. For a sphere, it's only going to give you one measurement on your sphere, and that's your radius. Also be careful, make sure it doesn't go all the way through the sphere. We only want it from this outside to the center point. We only want the radius. So, the radius is cubed in this situation. And we have 4/3 times pi times r cubed. So these two are just constant numbers. There's nothing we're plugging in. We're only plugging in for r. So we have 4/3 times pi times my r cubed. So let's say my radius here is 6. 6 would go in for r, and we cube it. Now, 6 cubed, that might be a little hard to do in your head, because 6 times 6 times 6, that's how we represent 6 cubed, is going to be a little hard to figure out in your head. So we can plug that in. You can either do 6 times 6 times 6, or if you have a little symbol like this, you can do 6 cubed, which is 216, which is the same as 6 times 6 times 6, 216. 6 cubed is 216, so we have 4/3 pi times 216. Plug that into your calculator now. So 216 times And if you're doing 4/3, make sure you put that in parentheses because it will do it out of order if you're not careful with that. So just put that in parentheses because it's 4/3 times pi. Or if you can put it in a fraction, that works too. But otherwise, I'd put it in parentheses because if I take this out of parentheses and I don't multiply it first, that'll affect the outcome of my calculation. So it'll be 904.8. Whatever my, so I'm not going to put a label on this one, but I'm going to say units cubed. So most of this is going to be calculator work. You need to plug these into your formulas. And you can do that right away, or you can solve it out a little bit at a time. Whatever works best for you. So this is sphere. This is my sphere, cylinder, cone. They have a little information on those pages I showed you before if you want to look at those. Those are on pages, I'll look them up real quick so you can have everything in this video. I believe it was 598, 606, and 590, I believe. Those just have information on what the cylinder is, and they also have the formulas on there. So that's what they have on there. But the formulas are a little weird on there, so I would work with these formulas that I gave you here. Work with those formulas, and then the definitions are in there. You can see examples in here, but I would work with what I gave you here. That should be helpful and help you work through this assignment that I'm going to have you do today, which is going to be a worksheet. So again, email me any questions you have. Hopefully this helps you out and it'll help you understand what you need to do for this assignment. If not, email me. I can help you. Just let me know. I can send you a video again, or I can send you another email trying to explain it more. Whatever you need, just let me know. If it doesn't make sense even after explaining it again, keep letting me know so I can keep helping you. All right. Thanks. Good luck on the assignment.